So what we're going to look at now inside of this video is we're going to look at the confidence interval for the mean or proportion, and we're going to look at some key terms and information. So we're basically going to talk about the overall structure of a confidence interval. The big ideas for confidence intervals are the same no matter whether or not we're using a mean or we're using a proportion. So let's look at first, what is the confidence interval for the mean or proportion? Okay. A confidence interval for the mean is an estimate for the population mean. A confidence interval for the proportion is an estimate for the true proportion. We use sample data to find the sample mean and standard deviation, and then we use that to construct the interval. Or we use sample data to find the sample proportion, and then use that to find the confidence interval for the proportion. So the first part that we want to get about this confidence interval is this thing called the point estimate. Simply put, the point estimate is either, in the case of a confidence interval for the mean, a sample mean, or it's the sample proportion. So that's the best information that we have about this particular population. It's all we have, in fact. It's the sample information. It's not great, though, because it's only a single point. So what we want to do is we're going to say, okay, we're going to construct this interval. And this interval is going to allow us to have some what we call margin of error. So in the middle, we're going to have x bar, or we're going to have p hat. That's what's at the middle, and that's called our point estimate. And then if we go in the negative direction, a certain amount, we get this thing called the margin of error, right? And that's how far away we are from our sample mean, okay, to the lower limit. So down here we have the lower limit of our interval. So from the sample mean or sample proportion, the point estimate, to the lower limit, that distance is the margin of error. And because we want to be symmetric, if we go above or we go greater than the point estimate, we're going to go the same distance, the margin of error, and that's going to be our upper limit. And I'm going to give you some examples of how this works in later videos. So that's basically what a confidence interval is. That margin of error is our buffer zone. It says, well, our parameter, p or mu, is somewhere in there, I think. Right? I have pretty good confidence it's in there. Right? What we call, we're going to talk about confidence levels in a minute, but that's kind of the idea. So let's talk about that. So we've got this thing where we're creating an interval. An interval is a range of numbers, okay? And that range of numbers is going to estimate our population mean or proportion. So the confidence level will imply how likely it is that a confidence interval that we create will include the true population mean or the true population proportion, okay? And so the higher the confidence level, the bigger the interval will have to be. And the higher the confidence level, the larger the critical value is, which is what increases the size of the interval. So let's give it kind of an idea here, all right? If I want to be, say, for example, 90% confident, right, I'm going to have a fairly sized interval. I'm still going to have x bar or p hat. I'm going to have my point estimate at the middle. I'm going to have my margin of error, okay? But it's, let's say the margin of error here is 2. This is just an arbitrarily chosen one, okay? So this one here is going to be x bar plus 2, and this one here will be x bar minus 2, say, for example. So we'll have this one not be a p. Now, what if I wanted to go to 95%? Well, 95% is I'm now more confident. To be more confident, I'm going to need a wider interval. And so consequently, I'll have my x bar here, okay? But now let's say, for example, it's going to widen out. It's going to increase my margin of error. My margin of error goes up to 2.5. So this one here, okay, here's 2.5. We'll say this will be x bar minus 2.5. And this will be x bar plus 2.5. That's the margin of error, so that's 2.5. This one here will be x bar plus 2.5. Okay? And you want to notice that all we're doing is we're taking that point estimate and we're adding it, right, to get the upper bound and subtracting it to get the lower bound. That's always what you do in a confidence interval. That's just how they work. Okay? And now let's look at a 99%. In a 99%, we're going to have x bar again, but now we're going to widen out even more because we want to be even more confident that we're going to get the actual true mean. And so now let's take, for example, we'll make this one have a confidence level of 3. And so now that's our x bar minus 3 over on this side, and x bar plus 3 over on this side for the upper limit. Okay? So basically that's how we think about confidence levels. A confidence level basically tells me how likely it is that I'm going to get the true mean. If I want to be more confident, and if you think about that, if I want to be even more confident that I'm right, I'm going to have a wider interval. That's the idea. Okay? And so, as we increase our confidence level, we increase the size of our interval. Okay? Now, what do we mean when we say that we're 95% confident? That the true mean is in, say, the confidence interval. We're saying that 95% of the confidence of the intervals that we construct will contain the true population mean. Or we are stating that 95% of the intervals that we construct will contain the true population proportion, depending upon which one you're doing. So what we're saying is that not that this one that I just constructed actually will contain the true mean. Instead, what we're saying is that we believe that using this method, right, will get us the true mean 95% of the time, right? So we are confident in our process and not in the actual interval that we construct. How that's important is because that gives us a difference between confidence and our chances. So it is not the case that our interval has a 95% chance of containing the true mean. Either the interval contains the true mean or it doesn't. It doesn't matter one way or another, right? Either it has it or it doesn't. So it either has a 0% chance it has it or a 100% chance. Instead, we're saying that 95% of the intervals that I construct will actually contain the true mean. And that's what we mean when we say that we are 95% confident. Okay, now let's just kind of review. This basic construction of the confidence interval is going to start out with the point estimate in the middle. Okay, and then we're going to go up by the margin of error. So this will be the point estimate minus the margin of error. Excuse me, plus the margin of error on the top end. And then this one over here is going to be the point estimate minus the margin of error. Okay, great. So that's basic idea of confidence levels, confidence intervals, and what do we mean by being confident, and how we actually construct an interval. We'll do some examples of this in just a little bit in some later videos. Now, a big question that we have is how do we decrease the size of the confidence interval? Well, you are not going to need to know how to actually find a confidence interval for this test, but what you are going to need to be able to do is you're going to need to be able to tell me, well, how do I decrease the size of a confidence interval? That is how do we increase what's called precision, right? That is that we get a better and better and better estimate. So what we're going to do to decrease the size of the confidence interval, right, we need to decrease the size of the margin of error. And what I'm going to look at is I'm going to look at, one, a t-interval, okay? So my margin of error for the t-interval is going to equal t alpha over 2 times s over the square root of n. In the case of a z, it's just going to be sigma over the square root of n, so it's basically the same. And then the margin of error for a proportion, so here's the mean, and the one for a proportion is going to be the margin of error equals z alpha over 2, right, times the square root of p hat times 1 minus p hat divided by n. Okay? Now, really important. For this exam, for the final exam, you will need to be able to use these given an equation sheet. For this exam, you just need to kind of like, you're not going to be actually finding these. I'm going to use these for demonstration purposes and so that you can study. Not because you actually need to know how to find a margin of error using these formulas. Let's just take a look then. Stated that, let's take a look and say, okay, well, what happens, okay, when I increase n? Okay, so by increasing n, right, n gets bigger. What I'm doing is I'm now dividing by a larger number. Okay, so as n gets bigger, the margin of error is going to get smaller. The margin of error will get smaller. And that's just true. That's exactly what's going to happen. N gets bigger, n goes up, margin of error goes down. Okay? Same thing over here, you can see it. As n goes up, the margin of error is going to go down. In both cases, as we increase the sample size, we get a better and better estimate. And that kind of makes sense from a theoretical standpoint too, because as I increase my sample size, I'm actually getting more of the population into my data. So consequently, I'm getting more information. More information is better, so it's going to give me greater precision. So big deal here, as I increase n, my margin of error goes down and it decreases the sample size, decreases the size of the interval. Now, there's a second way that we can do this, and it kind of has to do with what we talked about when we talked about confidence levels. The more confidence that we have, okay, the bigger we need to make the interval so that we're more confident that we're going to get the right answer. Okay, so if we decrease our confidence, right, if we go down from 99% to 95%, okay, decrease the confidence level, what we're going to do is decrease the size of the interval. Okay, so we're going to decrease the size of the interval if we decrease the confidence level. And those are our two ways. I should note the standard deviation, this thing right here, okay, and the sample proportion, which are also parts of that margin of error, right? The standard deviation cannot be manually changed. It's part of your data. So consequently, there's nothing we can do about it. We can't manipulate it to decrease the sample size. So that is not our answer. We can't manipulate it to decrease the sample size, so that's not our answer. Okay, cool. So now, finally, so those are the two ways that I can actually decrease the interval size. Either I go in, I increase the sample size, okay, or I decrease the confidence level, okay? Now, how do we determine if we're going to use the interval for the mean or the proportion? Well, basically, it's going to tell you either you're finding the confidence interval for an average or mean, or you're finding a confidence interval for a percentage or proportion. Okay? Percentage and proportion is proportions. Okay? Confidence intervals for means, averages, and means. So we can actually just put those in there. This is, right? Averages and means. That's a mean. Percentages and proportions. That's a confidence interval for proportions. Excuse me. Let's make that full-sized. Proportions. Finally, one last note. This is actually very important and very crucial. It's very crucial to this and to hypothesis testing. When we're constructing a confidence interval for the mean, so not for a proportion, doesn't matter if we're doing a proportion, okay? Only when we're constructing one for the mean. We have to decide if we're going to construct a t-interval or a z-interval. We use the z-interval when we have the population standard deviation, and we use the t-interval when we do not have the population standard deviation. So that's our basic thing. We figured out that we're going to run the test for the mean, okay? We've met our requirements, which are inside of the notes, right? And then we just want to determine, am I going to use a t-interval or a z-interval? And how we determine that is, do I have the population standard deviation? If I have the population standard deviation, okay, I'm going to use the z. If I do not, I will use the t. Really important. It's not do I have the standard deviation. It's do I have the population standard deviation. Do I have sigma? Okay, that's a different question. All right, so that completes my review of the key terms and ideas for confidence intervals.